Okay, so 7.2 law of sines. So we did some of this together. We talked about this. I will just say in one of the classes I wrote this exactly, but it can be used. The law of sines can actually be used for any triangle. So it can be an acute, an obtuse, which is oblique, or a right triangle. So you can have a right triangle and still use the law of sines. It's still going to work for you. Okay. And like I said before, I know this is like 3 fractions, but you can use these two and set them equal. You can use these two and set them equal, or you can use these two. You don't need all 3. Okay. You're looking for a pair, an opposite side that goes with its angle. And then that's how we set up the law of sines. Okay. So now we can solve for a whole bunch of other sides and angles, even if it's not a right triangle. So in our first example, I'm just going to show you the whole thing because we basically did it, okay, together. So we set up the triangle, and you're going to make sure that if you have to draw your own triangle, you're going to make it semi-accurate. So when you see that 35 degrees and the 20 degrees, you're going to think in your head, well, I'm not going to draw it so that it looks like this, because that's not accurate. That would be like 60, 60, 60, right? So if I think about the other angle, it's going to be big, right? So I asked, like, would the C be big or small? Well, it would be big because 35 plus 20 is 55. You subtract that from 180, which is a triangle, and that's 125. So you would need a 125, at least like a nice obtuse angle. And then you don't want to put that in the middle of a triangle because these two angles are different. So it's not an isosceles triangle. It's got to be like shoved to one side. Okay, so you want to draw it kind of nicely so it represents what's going on. And then we filled in all the other sides and the other angles. And we realized, okay, once we get angle C, we actually have a pair. We have sine of 125 over 15, and we can use that for both of the other sides we're trying to find. So then we have sine of 125 over 15 equals sine of 35 over its opposite side, which is A, cross multiply, divide this to the other side to solve for A, plug that into your calculator, maybe round to the nearest hundredth, whatever the book asks for, whatever the problem asks for. Make sure that you are labeling your answer. Okay, and then what I said also was from here to here, if you skip from here to here, I'm cool with it. I'm down with that. So you can see this one I skipped to here. So I knew that if I cross multiplied, I would have B next to this. So that would have to get divided by those two. So those two divided by sine of 125. So if you skip that step, it's okay, but you do need this step. So you need this, put it into your calculator, and then final answer. Okay, make sure you label. All right, so you are writing all of this for number 2. You're going to write all of this for number 2. To measure the height of a mountain that he can't cross, that's important. To measure the height of a mountain that he can't cross, a surveyor takes 2 sightings of the peak at a distance of 900 meters apart. The first, there should be a T here, the first angle of elevation is 47 degrees and the second is 35 degrees. If the transit is 2 meters high, okay, here's what a transit is. You stick it into the ground, and then 2 meters above that, above the ground, is this thing that you look through, okay? So imagine this pole that you stick into the ground, and then 2 meters high, you look through something to look at the top of the mountain. So that's the transit, okay? And then it says, what is the height of the mountain? All right, if I was gonna do this for homework, I wouldn't write every single word. Right now you are. But for homework, I would write something like height, measure H of mountain, comma, can't cross. 2 sightings, 900 meters apart. First angle 47, second 35, transit 2 meters high, H equals question mark. That's what I would write for the entire question for homework, okay? Okay, so let's think about this for a second, and I am going to use a separate sheet of paper. That's a little messy, but that's okay. So if I was going to draw this situation, then I need the height of a mountain, and I can't cross it. All right, so there's this mountain that can't be crossed, okay? So here's my mountain, and it can't be crossed. So he's like over here somewhere, and he can't cross over it. So he's taking two sightings. Okay, and I'm trying to figure out the height of the mountain. All right, so I'm looking for H basically here. Okay, and then there's the like regular land. All right, and then he takes two sightings that are 900 meters apart. So the two sightings aren't going to be here and here. The two sightings are going to be on the same side. So over here somewhere and then over here maybe are your two angles of elevation. The first one is 47, the second one is 35. So first and second versus first and second. Well, I'm going to think which angle is smaller, which angle is smaller. This one's smaller. This one, if we go farther away, it's smaller, right? This is 35. This is 47. Okay? 900 meters apart. So is this 900? No, these are 900. So this is 900 feet. Okay. And then what about the transit? Okay, oh, this is the transit. Okay, so remember you stick something into the ground. So this is like where your eye is looking. This is a creepy eye. But this is where your eye is looking, and it's on this pole in the ground. And this is 2 meters high. Okay, so is it me? Oh, 900 meters. Sorry. Okay, so this is why I have scratch paper here. So let me show you my little bit nicer drawing, but that's generally how I get the drawing. Okay, so here's my slightly nicer looking drawing. So same kind of thing, right? I didn't draw the mountain, but same kind of thing. So I had 35, I had 47, I have my height. Okay, notice there's a lot other things, but that's okay. I have my 900 at the same place. I have my 2, creepy eye, at the same place. Okay. And then how did I get this 133? Why would I even need it? Well, maybe I need it, so let's just find it. And how did I get it? Oh, it's a supplement of 47. That makes sense, right? So it's on a line. Okay. How did I get the 12? Well, this tiny little triangle is this plus this, subtracted from 180, is 12. Okay, how did I get the 43? Well, that's a right angle because it's the height from the ground. So 47, this must be 43 because you add that up to get 90. Okay, so I have all of these numbers and I also added in an x. Okay, so if I don't have x, that's okay, but I'm going to need it. So here's why I need it. Because when I look at this so far, if I'm trying to find h, and all I know so far is my side angle, right? So that's what I'm looking for, a side angle and a side and an angle. Okay, so here's a side, here's an angle and an angle and an angle. So I have 3 angles and 1 side. All right, but then I need another side, right? Because I'm looking for that side. So I either put an h here, an x, sorry, here, or I can put an x down here, but it's really up to you. I think this one's better because it's next to another triangle that has a bunch of information. So this other triangle we're going to get to use in order to find x, and after we have x, we can use the law of sines to find h. Because if we can do, let's say, sine of 47 degrees over h equals sine of 90 degrees over x, right? So I just need x. Okay, well, how do I get x? Let me just look at this skinny triangle. Oh, that's why I got that 12, because sine of 12 over 900 equals sine of 35 over x. So did I need that 133? No. But sometimes they just, I want all the information to help me, okay? So we'll start with that. Sine of 12 degrees over 900 equals sine of 35 over x. And then you solve for x. Notice that I did not write a final answer because x is not our answer. So then I use x right here. So I can use the law of sines, or, the law of sines literally is like sine of 90 over x equals sine of 47 over h. But then instead of that, I just decided, well, if I have these 2 angles and then I have an x and an h, if I want to use this one down here, have an opposite and a hypotenuse. SOHCAHTOA, I'm going to do this. Sine of 47 equals opposite over hypotenuse. So there's different ways that you can solve. Okay, I still have an x here, but I already know what x is. It's in my calculator, so I save it in my calculator. All right, don't write it down, save it in your calculator, just write down a little bit of it. And then solve for h. So now in your calculator, you can just multiply whatever you have by sine of 47 degrees, and then you have this, and notice that's not a final answer. How come that's not a final answer? Because the transit is 2 meters high. So this whole thing should be plus 2. So my final answer is that. And then now I write down my decimal, and then, you know, I label my answer. Okay? So I know that one was a little bit different, a little bit crazy, and that was, yes, that was number 2. There's so many different ways that you can do it. Some people, instead of finding x here, they find x here. Because they have one big triangle, they have the 35, the 90, and then this makes 55 degrees. And then they use this as a big triangle, and, you know, that helps them. So it's up to you, and it depends on the problem. You know, if you get the right answer, then you did it right. Okay, so ambiguous cases, and we talked about a lot about ASS today. So how come ASS doesn't work? So I actually forgot to show you guys a video. If you YouTube a video of why ASS doesn't work, or like triangle congruence ASS, then you'll see why it doesn't work, okay? But what happens is when you have ASS, there's different scenarios. So ASS means angle, side, side, in that order, and we talked about today how I like to draw it so that the angle comes first on the left side, and then the S goes up, your S goes up, and then back down. So it goes up and then back down. How come it looks different here? So if A is acute, then it's going to look something like that because A is really small. But if A is obtuse and I have my base as a horizontal, which I like to draw horizontally, otherwise it looks all weird and, you know, all the triangles look crazy. If this is horizontal and A is obtuse, then it would go this way because a right angle is here, acute's over here, so obtuse would be here. So if it's obtuse, then it's like this, and then it goes that way. So if A is acute, there's a problem because this does not give us enough information to know about the triangle, okay? I drew a height here, so you're drawing the triangle, and then realize this is the height of the triangle making a right angle. So if A is less than B, which it looks like it is, but then A, look here, is bigger than B, or sorry, A is less than B. Just kidding. Okay, A is less than B. So these two, 1 and 3, are A is less than B. So A is less than B, and then in this scenario, A is bigger than H. So A is bigger than H. There's 2 triangles that can happen because this A can literally, this little length can swivel over to the left side and make a triangle that looks like that. Because that A will still be the same length, and it'll be angle, side, side over here by my finger, okay? And this angle up here doesn't matter for ASS, and that's why ASS doesn't work, and it sucks. But if A is less than H, imagine A being smaller. If A is smaller, but the height had to be the same, like if A was 4, but the height was 6, then A would never reach down. It would never get to the bottom of the triangle, the base, so that's why it says no triangle. And then if A is bigger than B, it would make 1 triangle, okay? I don't memorize this. I'm gonna say that again. I don't memorize this. Instead, I just start solving for a triangle, and when my calculator says no answer or whatever, error, then I know there's no first triangle, or if I get to a first triangle and it says no answer for the second one, then I know there's no second answer. But I always try to find all 3 answers. If A is obtuse, so A is big, then if A is bigger than B, I see there's a triangle that can happen. But if A is too short, if A is only this long, then it never reaches down here, so that's why it says no triangle. So it is possible for ASS to give us no triangle, one triangle, or two triangles, which is why ASS did not work 2 years ago, and it still does not work. And that's why it's annoying and we have to draw it a certain way. Okay, so on the back, we started talking about these, and then you wrote this down, okay? So, number 3, how many triangles are possible? I don't answer that first. I always do this first. If there's one or more, solve them. So I just start solving. And then you wrote this. You want your S to go up, not down. You don't want a droopy one. And at the end, you give it a little swivel. When I talk about a swivel, I'm talking about the last piece of your ASS, right? The last S. So this swiveling back and forth, because it can swivel over to the left and it can make a much smaller triangle, okay? So at the end, you give it a little swivel. All right, so I'm just gonna show the whole thing for this one. For A, how many triangles are possible? Okay, let's say they give you an angle C, they give you a little B, they give you a little C. I always start drawing my angle from the left side, and I always go up. So I go up first, and then it has to spell angle, side, side. So I go up and then back down, okay? I always leave it open in the beginning because I don't really know if it's a real triangle or not until I finish solving it. This one is not. We'll talk about that. And then how do I know that the 60 goes here? Okay, well, here's the 60 degrees, right? And then what would go over here would be little c. So if I'm given B equals 60, then 60 goes here and little c goes here. So always draw the angle, whatever the given angle is, on the lower left side. And then you're going to go up, and then you're going to come back down. So your ASS goes up, not down. Okay. And then using this information, so now I can fill in like B and A. Sine of 60 degrees over 50 equals sine of B over 60. That's the only thing that you can come up with here, right? Like you can't solve for anything else anyway. There's no big A, there's no little a. So then you cross multiply, and then you solve for sine of B, and then you are like, well, how did I get B? Oh yeah, sine inverse. So I want to just make sure that you see this, but if you did it already, that's fine. But make sure that you know how to do this and can put it in. So sine inverse of this fraction. I'm going to do alpha y equals, enter. And then on the top, it's 60 sine of 60 degrees. And on the bottom, you have a 50. I don't need to close the parentheses. You can if you want. And then I press enter. And it says error. When it says error, you know what that means? That means that this number was too big or too small. So basically your sine values, remember how SOHCAHTOA sine is opposite over hypotenuse? If the opposite is, the hypotenuse is always the biggest side. So if the top number is too big, which we wouldn't really know because we don't know sine values, we're not calculators, but if the top value is too big, it's not actually a triangle, it's not possible. So that's why it says error, and that's not a wrong answer, it means there's no triangle, okay? Okay, so we started this one together, and then we got to like here, okay? So again, you start on the lower left corner. So you always start like horizontally, and then you start on the lower left corner, and then you draw up, your ASS goes up. And then you think about, before you draw this, you think about, okay, how long should this be and how long should this be? Well, if this is 20.5 and the opposite should be 12, that means that this should be 31. So this should be nice and long, and this should be shorter. Okay, so even if this was longer, that'd probably be better, but that's okay. So this is 31, and then this is 12. All right, so I have my ASS, angle, side, side in order. Okay, what can we possibly solve for? We can solve for B. So I have this angle and this side. I don't have this angle, but I have this side. So I do the same kind of thing, except this time it gives me an answer. Okay, so I take that answer, and then I'm going to actually do this in my calculator. So you're going to have to bear with me a little bit because I need that number and I want to show you. And you're going to do it with me too, okay? So if you haven't done it already, do it with me too. So sine inverse of alpha y equals 31 sine of 20.5 On the bottom, you have a 12. I'm going to press enter. See, I didn't even have the parentheses. It was fine. 64 point da 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 da. I'm going to keep this on my calculator, but I'm not going to write it down. And then that gives me my first scenario of what B could be. And it looks like it could be about 65 degrees. That looks accurate. But remember when you draw this, so when you draw this, you are drawing it kind of the same way, and then you have that little swivel. So the 12, so that's like a little like bolt. It bolts the 12 into place, and the 12 swivels to the left, and now this is 12 and this is 12. This is an isosceles triangle. Isosceles triangles have congruent base angles. So if this is 64 degrees, then this is 64 degrees. How do you get the one next to it? It's the supplementary angle to this one. So this and this are the same. The one next to it is the supplementary. So why I drew this is it helps me get that same thing. So this is the same thing right here. But then I needed to see kind of what it looked like. So I drew it like this, and then I drew it like this. Okay? So you can see this makes sense too. 115, that looks obtuse. That's 115. That makes sense. Okay? And this is still ASS, ASS. These are both angle side, side, but see how they're not congruent? Obviously, they're two different kinds of triangles. So that's why ASS sucks as congruency. So we're not saying they're congruent. We're saying these are two possible triangles. Okay. So then what we did is we said, okay, based on this, I can see that I can still use sine of 20.5 over 12 equals, and then I already did B, okay, so I found two values for B. What about C? So sine of big C over little c. Okay, if I want to solve for little c, then I cross multiply, and then I divide by sine of 20.5, and I get this, okay? Why do I do that? Because now I can very quickly, notice how there's no more work on my paper. I just have answers. So how did I get, I'm going to uncover this, and then I'm going to show you one at a time. How did I get these other answers? So this one I already found, so I just write it down, 0.8, okay? This one, how do you get the third side of a triangle? Well, I have this, and then what, plus 20.5. Actually, insert 180 minus that quantity. So let me just do it in one function. There you go. Okay, or one expression. So now that gives me my C, which looks like, you know, this is less, or this is a little more than 90 degrees. That makes sense. This is a little more than 90 degrees. I can see it in my picture. Now that I have C on my calculator, I can use this formula. So 12, actually I'm going to make it a fraction, right? So alpha y equals 12 times the sine of, copy paste, over the sine of 20.5. So see, that's the same thing, but I filled in C that I just found using my B value up here and my A value, okay? So I plugged in, and I have my 34.15. Yes, yes? Maybe so? Okay, so that's my first triangle. My second triangle, now I have my new B, which is 115. Okay, how do I solve? So I have my 115.2. That is, I still have it in my calculator. It is right, where is it? Right there. Okay, so I already wrote that down as my final answer. How do I get C? Well, if this is 115 and this is 20.5, I should add those up and divide, and subtract from 180. So I'm going to grab this, copy paste. I'm going to add it to 20.5. I'm going to subtract 180, but I know it's going to be negative, but that's okay. So this is positive 44.3 because I subtracted the wrong way over here, which is fine. So I have a positive 44.3. Okay. I'm going to actually multiply that by -1 to make it positive because I want to use it for this equation. So now I have this, I have this. I'm going to find my last little c by using this equation. Again, I'm going to go ahead and do my fraction, and then 12 times the sine of, grab that angle, divided by the sine of 20.5 equals, there we go. So you can't just watch me put things into a calculator. You need to do it, because for homework tomorrow, you're going to do it. And then for homework the next day, you're going to do it. And then you're going to be asked to do an entire problem like this, like B. You're going to have something like A eventually as well. But B is the serious one where you have to like, oh, there's two options, so I have to keep going. And then you get two full answers. This is one triangle, this is another triangle. You had three pieces of information, and then now you have another three, you have another three. These are my two options for triangles, okay? If you just have one, that is less than half credit, because you don't even realize that there's another answer, okay? There's three other answers. All right. One question that some people ask is, how do I always have to like find all of the answers? My answer is basically yes. So at some point, you get stuck in your calculator. So if you can't find the first B and there's an error, then there's no triangle. If you can find the first B, then you're going to at least have one answer, and then you're going to subtract that B from 180, and you're going to find the supplement. And then if that gives you like a negative or something super weird like that, if you're doing this problem and you find that like, oh, I got a B and then I found C, but my C is negative, well, then that means that there's no second answer. That means there's only one triangle and you're done. So as soon as you get something that's an error or like a negative angle or a negative side or something, you're going to be like, well, that doesn't make sense. And then that's not going to be a possible triangle. Okay, so I know that was like serious business, but this was something I wanted to explain very fully. So good luck, and then I'll see you in a little bit.